Okay, so today we're going to talk about the systems on the tracker sled, starting with the solar modules themselves. Now we talked about that each of these is a 72 cell panel, bifacial, right? So it can absorb energy on both sides. But we haven't talked a lot about the wiring yet, how these panels are wired together. So each panel has two leads to it, one positive, one negative. The panels are 400 watts nominal and they operate at 45 volts. So the most recent codes will allow these systems to operate at 1500 volts. So actually it's even written on these cables. So, and that's 1500 volts DC. Each one of these panels will be connected to a neighboring one in series, not in parallel, right? So their voltages will add. So we can have up to 33 panels here in a single string and 66 panels for a complete length of the tracker sled. So the wiring will be fairly straightforward, at least on the powering side here. And the wiring will need to be tucked away and cable tied as we go. I'm just going to simply tack it away here. The other component with a utility scale installation is a SCADA system, which is more a communication system, supervisory control and data acquisition, because you'll have to be monitoring the panels and their power production throughout a typical day. So the other component that we're going to add with the tracker sled is this idea of monitoring the ballast. And this is just, you know, as I'd mentioned, these tanks are both 111 gallon tanks that are repurposed from the marine industry. Each of these tanks had a level indicator, right, that was connected to a communication system. So you can always tell the fuel level. In a similar fashion, we'll have to install something like this in each of the 5 ballast tanks that makes up the tracker sled, so we can monitor the level of the ballast. So if there's a problem, say a leak develops, we can immediately know about it and make a necessary repair. So in this case, the sort of ballast will be part of that overall SCADA system. The other thing we want to talk about today is openings in the tanks themselves. What will they look like? How many do we need? And certainly we'll start here with a fitting that we have seen before in a previous video. This is actually just a cap. Again, this is the plug and socket sort of fittings that have cam locks on it. But we'll certainly need at least one opening in each tank for filling and emptying the tank. When we are emptying the tank, we'll need a hose, as we saw before, that can take a negative pressure and actually act as a suction hose, so that we can simply put this on, lock the cams in place, and away we go. So that is one sort of fitting that we'll definitely need one per tank. The other thing we were just thinking may be worthwhile is to thinking about some sort of handhold here. Originally thought of this in case we needed to use a submersible pump, just a simple submersible pump, where you could have a gasketed fitting that you would just merely spin out and gain access to the inside of the tank, so that you could take a submersible pump like the one I have here, which is roughly 125 gallons per minute, and you can actually just toss it actually in the tank. Say if I had to evacuate the ballast to make a repair or something like that, and then at that point I can use a discharge hose, right, that's just super simple, like a ribbon that will just inflate, almost like a fire hose that you see, because that's not under negative pressure. We're not so certain that we need to do that for this purpose. It may just be practical to use the exact same pump when you actually relocate tanks. But this is an eventuality. The other thing is it could be a useful just handhold that if I had to gain access, say, to a fitting like the one we just saw, or one of these other fittings on the inside, that might be really useful. So that's something we're definitely thinking about. You know, instead of these threads being in a different component, we're really just going to be able to mold these threads, these female threads, directly into the tank itself. So these are still at the stage of being mock-ups of what we're thinking about. Again, the idea is to really limit the number of pieces and parts. The last opening I want to show you today is this idea of a vent. And we know that although the tank is strong, it's not made to withstand pressure like a pipe. So it can't go into negative pressure or positive pressure. It's just not designed structurally to do that. So we need to be able to have some sort of vent here. And the vent that I have here can serve two purposes. It can let air in and out of the tank while still protecting the ballast from evaporating at a large scale. This is lockable also. The other thing is we're thinking of both these fittings can occupy the exact same opening. So in that way they're almost reversible, so that we really limit the number of pieces and parts that we have on a tracker sled.